Hi, everyone. Before we get started, I want to say thank you to everyone at Ruby Central, Confreaks, and all of you working hard behind the scenes to make RailsConf happen this year. It wouldn't be the same without you. I'm so grateful to be keynoting again, and I'm hopeful that next year we'll all get to be together in person. As Penelope mentioned, I'm Eileen Uchitelle. If you want to connect after the conference, you can find me on GitHub and Twitter at Eileen Codes. I'll also be on Discord to answer questions after the talk. I'm a principal engineer at GitHub. I've been at GitHub for 4 years now, and I spent the first couple of years here getting us off a custom fork of Rails 3.2. Through that work, we now run the GitHub monolith in production on the Rails main branch. Considering how far behind we were, this is a huge accomplishment. These days, I spend the majority of my time consulting on architecture changes, advising on how to reduce our technical debt, and working to improve Rails and Ruby upstream so they can continue to support our applications for the long haul. My goal in all of the work I do is to make Rails and Ruby more scalable, user-friendly, and stable for us at GitHub and the entire Ruby community. I'm also a member of the Rails core team, which is a group of 12 people who drive the future of the framework. We decide what features should be in the next release, what behavior we should deprecate, and are responsible for the stability, security, and functionality in every single release. I've been contributing to Rails since 2014, and I've been on the Rails core team since 2017. My talk today is quite different from talks that I've given in the past. It's a lot more personal and less technical. In the first part of this talk, I'm going to tell you my story, how I started programming, how I got here, and along the way, I'm going to tell you about all of the things I thought I couldn't do. We all struggle with self-doubt, and while it might not be obvious now, I used to be terrified of public speaking and contributing to Rails. In the second part of this talk, a guest speaker is going to join me, John Carpezzi, known online as C. John Run, and we're going to talk about how we started working together and how pairing is a great way to get unstuck when working on hard problems. We're also going to do a deep dive into connection swapping code that we wrote for Rails, because it wouldn't be an Eileen Codes talk without some technical content. And in the third part of this talk, we're going to look at ways that you can work through the things that you think you can't do and overcome your own self-doubt and fears. As I said before, I'm going to be on Discord after the talk to answer questions. I got into programming almost accidentally. From 2005 to 2009, I attended the State University of New York at New Paltz. I've always loved creating art, so when I got accepted to New Paltz, I knew that I wanted to pursue a photography degree. However, I had some pressure from my parents to pick something more stable, like teaching, because they didn't think a Bachelor of Fine Arts was going to bring me financial security. I obliged for a hot second, but quickly realized that while I have a lot of respect for educators, it just wasn't the right path for me. I changed my major to a Bachelor of Fine Arts in photography before my first day of freshman year. Throughout college, I didn't have a clear idea of what exactly I wanted to do once I graduated. While I love photography, the default careers like wedding photography and portrait photography just didn't interest me. I enjoyed planning scenes and editing my photos, but ultimately wasn't sure it was actually a career that I wanted to pursue. To help me figure out what I wanted to do, I took a lot of other classes offered by the art department. I figured if I could do everything from painting to design, I'd eventually find a job that I enjoyed, fit my skills, and provided stability. In addition to my courses, I held various jobs and internships, all with the goal of figuring out what it was I wanted to do after I graduated. I worked at Sears Portrait Studio, which taught me that I don't like corporations or child portrait photography. I worked as an assistant for an editorial photographer, which taught me how important organizing your finances was, but ultimately that I didn't want to work in someone's shadow waiting to make it big. I worked as a design intern at a local arts magazine, which taught me that print was a dying industry, but gave me some connections that helped me get a job later on. In the fall of 2008, I registered for a printmaking class because it's the perfect blend of painting, photography, and design. Unfortunately, the school decided to not allow any printmaking majors to join the class, so I had to find a new one that fit into my schedule. The only class that worked for me was an Adobe Flash class. I signed up for this class because I figured I could at least learn how to make a portfolio website to find a job after graduation. I laugh at this now because Flash has totally gone from the web, but at the time it was a popular choice for advertising and websites. I also think it's funny that DHH mentioned Flash in his keynote yesterday. I'm no longer sure if this is a RailsConf or a FlashConf. Realistically, though, I probably wouldn't have gotten into programming if it weren't for Adobe Flash. I quickly became enamored with Flash and programming during this class. I remember our instructor very specifically did not want us to build a website for our final project because he said it was too hard and we didn't have time. Well, anyone who knows me at all knows that if you tell me something can't be done, I'm going to go do it. So of course, for my final project, I built a portfolio website to showcase my photography and design work. The next semester, in the spring of 2009, I signed up for an HTML and CSS class with the graphic design department. In this class, I was building relatively basic websites with tables, no less. And I'm not even sure that anyone who's learning HTML and CSS today even learns like how to make tables websites. But even so, I fell completely in love with web design and development. I asked the instructor how I could learn more about programming languages like Python, because it started to feel like a career that I wanted to pursue. I could have stability and be creative. The professor of the class asked me why I'd want to do that, because then I'm a programmer, not a designer, like it was a bad thing. I think he had this idea that programming lacked creativity and that by learning back-end languages, I was somehow giving up on design. I wasn't even a design major. What does he care? I'm glad I didn't listen to this professor and kept striving to learn more, because I probably wouldn't be here today if I had listened to him. After I graduated from college, I applied to literally any programming, photography, and design job within a 100-mile radius of where I lived in upstate New York. I had loans to pay, and I wasn't going to be allowed to stay on my parents' health insurance for much longer, so I had to find a job quickly. I was willing to do any job remotely related to my degree. In late summer of 2009, I was hired part-time at a dentist office marketing department. Yes, dentist office marketing. The setup was somewhat unique. In the front of the building was the dentist office, and in the back was the marketing and design department. My role at this company was web development and social media. The first thing they had me do was set up all the social accounts on Twitter, Facebook, MySpace. Y'all remember MySpace? And other social media sites that no one ever used and no longer exist, like Bebo. Like, why does a dentist office need to be on Bebo? I was also in charge of upgrading their WordPress install and making content and layout updates. I was the only person there that knew anything about web development, which was absolutely terrifying because I didn't know anything. I didn't enjoy this job for various reasons that I'm not going to go into, but I immediately started looking for a new job. A couple months after starting at the dentist office, I got an internship at a local web development agency making flash ads for their clients. In November of 2009, the agency hired me full-time as a digital designer. I was eager to learn more programming, and this was a good opportunity to use my existing skills while building new ones. The agency was small enough that there was a ton of opportunity to learn more, but not so small that there was no one who didn't know more than me. And when I first started working there, I only knew Dreamweaver, HTML, CSS, and the tiniest bit of JavaScript. That was it. I quickly learned that Dreamweaver was looked down upon in the industry, and pretty immediately switched to TextMate and later Vim. I worked there for 3 years, and in that time, I taught myself a lot. I learned PHP, Capistrano, CouchDB, everything from design to development to deployments. It's also where I started working with Ruby. I still remember the first time I got to work with Ruby. We had a few clients that had Ruby sites using Radiant CMS, and some clients that had Rails applications. Ruby changed everything for me. I completely fell in love with the language. It was the first time that I wanted to quit being a generalist and deep dive into a language so that I could understand how it was built and designed. Over the years at the agency, I taught myself basically everything. I knew that if I wanted to accelerate my Ruby experience, I needed more, something like a class. In the summer of 2012, I attended Big Nerd Ranch for a 7-day Ruby and Rails bootcamp. We spent 2 days learning Ruby and 5 days learning Rails. It was a great experience, and though it was a short course, it was a turning point for me. It was the first time that a language just clicked. I didn't feel like I was playing catch-up anymore. Big Nerd Ranch gave me confidence in my skills that I wasn't getting from teaching myself. While I learned a lot working at the agency, I had outgrown the type of work we were doing there. The work was fast-paced, and on any given day, a customer could ask for a last-minute website for a lobbying effort or other event. I was tired of building countless websites in WordPress, and I wasn't able to commit time to learning a single product or language in depth the way I wanted to. We had some Rails projects, but not enough for me to deep dive into that work full-time, so I started looking for a new job. I live in upstate New York, about 2 hours north of New York City. There aren't a lot of tech jobs nearby, and the ones that are here don't like to pay you market rate. So I focused on applying to companies with remote work. One day, I stumbled across a blog post on a website called rateroutes.com. The author, Stephen Ball, had written a post called "The Things Most Interviewees Fail to Discover." The post talked about things that interviewees should consider before accepting a new job, like, is this application so unstable that you're constantly getting paged in the middle of the night? What's a typical day like? How do teams manage tasks? And other useful questions. At the bottom of the post, there was a small blurb about the company that he worked for, FishMe, how he liked working there and that they were hiring. In reading the post, I felt like the job was meant for me. I wrote a cover letter, got my resume ready, and sent them an email. And a few hours later, I heard back and scheduled my first interview. After a few more remote interviews and a last-minute flight to Colorado where the team was meeting for Rocky Mountain Ruby Conference, I had an offer. I found out later that Stephen had written the post specifically to get people to apply for the job at FishMe, and clearly it worked on me. So in September of 2012, I started working at FishMe, where I was able to dive into a large production Rails application. The team was small. I was employee number 24, and there were only 4 other engineers. This allowed me to pick up any task that I thought was important or interesting. I earned the nickname Raid because I absolutely destroyed our backlog of bugs. In 2014, I worked on a project at FishMe that gave the sales team tools to create and delete data as needed for customer demos. While working on that project, I accidentally took down the MySQL database on a staging server because Active Record was generating inefficient queries. I learned a lot about database performance while working on this and found some new ways to make queries more efficient. I found the work really interesting and wanted to share what I was learning with the community. But I was terrified of public speaking. While I was terrified of public speaking, I knew this performance work would make a really interesting talk, so I started applying to conferences. I was a new speaker with barely any personal brand, so of course I got a lot of rejections at first. Finally, in March of 2020, I was accepted to speak at Mountain West Ruby in Salt Lake City. At the conference, I gave my first talk called CRUD, The Consequences of Not Understanding How Active Record Translates into MySQL, which is a very long title that I later made smaller. The idea of the talk was to encourage engineers to dig into Rails and really understand what SQL the Active Record methods for create, select, update, and delete were generating. For example, if you need to insert a lot of data, it makes more sense to do a batched query that doesn't fire callbacks over multiple create calls. In another part of the talk, I noted that calling delete all on a collection proxy would result in an inefficient query. This was notable because delete all is supposed to be a lot faster than destroy all, but it turned out there was a bug in Rails causing the query to use and in rather than the foreign key, which is really inefficient for queries that need to delete hundreds of thousands of records. Aaron Patterson was at the conference, and during the Q&A, he said that it sounded a lot like I had found a bug in Rails. He then asked me why don't they, meaning the Rails core team, fix the bug. I looked at him and said, I don't know, Aaron, why don't they? Afterwards, Aaron reached out on Twitter and said that we should pair on fixing the bug and delete all queries. I didn't have a lot of experience contributing to open source at the time. I had fixed a few things in Rack Mini Profiler, but contributing to Rails felt like it was on a totally different level. The next week, Aaron and I paired on the delete all bug, and a couple days later, I pushed up my first commit to Rails. We started pairing weekly, and to this day, Aaron and I still work on various changes to Rails and Ruby. I'm very grateful to him for reaching out and teaching me how to contribute to Rails back in 2014. Speaking at Mountain West changed the trajectory of my career and gave me an opportunity to contribute back to Rails. In the fall of 2014, I got an email from DHH asking me if I'd be interested in joining Basecamp. He had seen my work on Active Record and thought I'd be a good fit for the security, infrastructure, and performance team. While I enjoyed working at FishMe, it was impossible for me to turn down the opportunity to work where Rails was literally created. In my time at Basecamp, I worked on bringing system testing to Rails, improved the performance of integration tests, and I built the incinerator, which is an internal project that makes sure that when you delete data from Basecamp, it's actually deleted within the retention period. I think David talked a little bit about the incinerator yesterday. I also worked a lot on security at Basecamp and was responsible for patching the older applications when Rails had a vulnerability. In late 2016, Aaron reached out to me about an opening on his team at GitHub. I was learning a lot at Basecamp, but I thought it'd be fun to work with Aaron full-time. It was a bigger application with different scalability problems, and I found that interesting. I think if I had known it was going to take me 2.5 years to get GitHub off a custom fork, I might not have said yes, but hindsight is 2020. I started working at GitHub in January of 2017. In my 4 years here, GitHub has changed a lot. I upgraded us off a custom fork of Rails 3.2. We were acquired by Microsoft, and we've contributed a ton to Rails and Ruby. Over the years, I've made a lot of improvements to the scalability of Rails, most notably upstreaming our multiple database handling. We wouldn't be able to do this if we hadn't invested in upgrading and getting off a fork of Rails. In 2017, shortly after I was hired at GitHub, I was invited to join the Rails core team. I've been working on Rails since 2014, and in that time, I improved Active Record, made integration tests faster, built system tests, Getting onto the core team is one of my greatest accomplishments. It's a huge honor to be able to support Rails and our community in this way. I really, really enjoy working on Rails to make it better for all of you. Then in 2018, I applied to speak at RailsConf about the work that I was doing to upstream the multiple database behavior from GitHub to Rails. My talk was accepted, and a few weeks later, I got an email from Evan Phoenix asking if I wanted to keynote. I've been hoping to keynote RailsConf eventually, and when I got that email from Evan, it was the first time in my life that I cried from being happy. It was both exhilarating and overwhelming to be asked to keynote RailsConf. I talked about the work that we were doing at GitHub and how important it is for Rails to support applications as they scale. And fast forward to today, here we are at RailsConf 2021, my third time keynoting. It's such an honor to be one of your keynotes. I thoroughly enjoy writing and giving talks to all of you, and I hope that you enjoy them too. If you looked at my career and how I got here, you might think that it was easy or at least a little straightforward. But in order to do all of the things like keynote RailsConf and contribute to Rails and work at GitHub, I had to overcome a lot of self-doubt and internalized fears. There were so many things that I thought I couldn't do. When I first started programming, I wasn't sure it was going to be a job for me. There was so much I didn't know, and I didn't have any formal training. I had a degree in photography. I don't have a computer science degree. I also never excelled at math in school and was worried that to be good at programming, I had to be good at math. And the truth is, I'm not even sure I'm bad at math. I didn't fail any math classes, but I remember being told I wasn't good at it and that it wasn't something I was ever going to excel at. And that people who wanted to work with computers had to be good at math. Well, as most of you know by now, you don't need to be good at math to be good at programming. For some projects, of course, we need to understand mathematics concepts in order to build complex algorithms, but we don't need to know how to do calculus to build multiple database support into Rails. For a long time, I lacked confidence in my programming skills and spent a lot of energy hiding what I didn't know. Because I wasn't formally taught and didn't have a computer science degree, I thought I'd never be a good enough programmer to work somewhere like GitHub. It wasn't because I thought GitHub required a computer science degree or math or whatever. It was because I thought I couldn't teach myself the things that I needed to know to feel confident. I thought I'd always feel a little bit behind, a little bit like I was faking. I worked on building up my confidence and skills by saying yes to any opportunity that came along. I helped out people on Stack Overflow, I asked questions on Twitter, I joined mailing lists like Ruby Weekly, and I watched every RailsCast video. Every time I learned something new, I wrote a blog post about it, and I used my blog simultaneously as a way to remember how I solved problems and to help others having similar issues. The more I shared what I was learning with others, the more confident I got in my skills. Eventually, I realized that there was something that I didn't know the answer to in programming, that I could figure it out, or at the very least, ask my network for help. Another way I built up confidence in my skills was through public speaking at conferences. However, to do this, I had to overcome an intense fear of public speaking. I had a bad experience in high school, like all of us have, where we had to do a debate in class and it didn't go well. The topic we were debating was kind of heated and the teacher didn't really prepare us. The debate went so poorly that I vowed that I was done with public speaking forever. Oddly, this was an economics class and not a debate class, so I'm really not sure why we were digging into this topic, which clearly scarred me. But what I didn't know then is that there's a big difference between public speaking in school and on stage at a conference. In real life, you here are all rooting for me to succeed. No one, unless they're a real jerk, and then I have no idea why you're here. Why are you paying for a conference if you hope the speaker fails? No one does that. But in high school, we're not afforded that same experience. I was so afraid of public speaking that it felt like I might actually die from trying to do it. My fear of public speaking was up there with my fear of heights, which frankly, I haven't actually overcome. At the time, just the thought of getting on stage made me lightheaded and nauseous. I'm not quite sure how I overcame my fear of public speaking. I think that one day I just decided that I had to work to get over it. I realized that in order to grow my career, the next logical step for me was to speak at a conference. This doesn't mean that if you don't speak at conferences, your career's at a dead end. At the time for what I wanted to do, this was the right move for me. There are plenty of ways to get visibility in the community to achieve your career and personal goals if public speaking isn't for you. For me, I was inspired by all the speakers that I saw at conferences talking about their experiences. I wanted what they had to share some of the things I was learning with a broader audience and on stage. I also saw it as a major opportunity for growth for me. I originally was going to start out small with some lightning talks at conferences, but after writing a couple of those, I realized that if I put them all together, I'd have a full talk. So I literally remember thinking to myself, go big or go home, right? When I read the acceptance email from Mountain West Ruby, I thought I was going to pass out. The initial excitement at having my talk accepted turned into thoughts of, oh my, what have I done? Now that I had been accepted to speak, I had to actually write the talk, and then I had to actually give the talk in front of humans, people staring, judging, shit. Once I got over the initial shock, I started to work on the talk. I worked incredibly hard on writing that talk. I was terrified I was going to forget everything as soon as I got on stage, so I practiced for hours and hours and hours and hours and hours until I knew every single word by heart. I practiced at local meetups and tweaked my slides every time I got feedback. When I got to the conference, I was so nervous because there were a lot of famous Rubyists there, like Aaron Patterson, Ernie Miller, David Brady, and Sarah May. I'll never forget how welcoming and encouraging everyone was. While I was still nervous, my talk went really well, and I got a lot of great feedback from the audience. Then, a few hours after my talk, my jaw locked up. I had apparently been clenching my teeth for a week, and I could not eat solid food for a few days after the conference. Getting over my fear of public speaking was incredibly hard for me, but slowly, over time, with each talk, the anxiety lessened and it became more manageable. Plus, I really enjoy giving talks, especially to an in-person audience and live. The joy I get from speaking always outweighs the anxiety that I have. Each time I gave a talk, I got less and less nervous. I'll never be completely free of that anxiety. I spend a lot of time worrying that you all won't enjoy what I have to say, and I still spend a lot of time on my talks. Probably put on 250 hours into this one. But that fear and self-doubt is much less now than it was the first time I gave a talk. At least my jaw hasn't locked up again. The more we do something, the better we get at it, and the less we doubt ourselves and our abilities. While I'm now a maintainer of Rails, I wasn't always comfortable contributing to open source. I remember during my class at Big Nerd Ranch, learning about how Rails was open source and that anyone could change it. At the time, I thought, that seems cool, but I'll never be able to do that. Contributing to Rails felt overwhelming. It's a huge framework. I used to think that everyone on Rails core was far smarter than me, and that I couldn't ever possibly have anything to contribute. Even when I found the bug in delete all and gave a talk about it, I still didn't believe it was a bug until Aaron told me it was. I thought that if it worked in a broken way, it must be broken for a reason. But open source is just other humans building things and sometimes making mistakes. None of us are perfect. Even after pairing with Aaron to fix the bug, it took me at least an hour to open that first pull request. I sat there staring at the open PR button on GitHub thinking, what if everyone thinks my fix is bad? What if they don't agree it's a bug? What if there's a major flaw in the new logic? I can still remember how that first pull request felt because I still feel it every time I open a PR on a new project. Earlier this year, I sent my first pull request to Ruby. I had never contributed before because I don't really know C that well, and even if I did, the Ruby VM is incredibly complex. After the Ruby 2.7 upgrade at GitHub, I wanted to be able to tell the difference between the different types of warnings in Ruby. Prior to Ruby 3, deprecation warnings were treated exactly the same as other warnings. There was no way to tell the difference between them without regexing for the word deprecation warning. Just like with Rails all those years ago, making this change to Ruby felt hard. However, this time, I knew that just because it was broken didn't mean it was supposed to be and that I could fix it. And just like with Rails all those years ago, Aaron and I paired on it and he helped me figure out how to add a category to warnings so engineers could tell which ones were deprecations. Even though I'm now a seasoned contributor, I had those same anxious thoughts when opening the PR. What if everyone thinks my fix is bad? What if they don't like the feature? What if there's a major flaw in the new logic? These thoughts are so common when doing open source work. We worry that we're not good enough to contribute or that someone will reject our hard work. It's incredibly difficult to overcome these fears and doubts. I try to remind myself that a rejected pull request isn't personal. Most maintainers want your contributions, and even if they don't want a specific change, that doesn't mean you aren't good enough. Over time, I've found that the more I contribute, the less I worry what others will think. The only way to get better at contributing to open source is to keep doing it. The vulnerability that you feel might never completely go away, but I promise it'll get easier over time. I'm incredibly grateful to Aaron for helping me to contribute to both Rails and Ruby over the years. It would have been so much harder for me to get into open source without his guidance. And ever since Aaron invited me to pair with him and taught me how to contribute to Rails, I've tried to invite others to pair with me when they find bugs or have a general interest into diving into open source. Finding someone to pair with that you get along with, trust, and work well with is one of the best parts of programming. So for the last 2 years, I've been pairing with a coworker at GitHub, John Capezzi. He's going to join me now, and we're going to talk about pairing and some of the work that we've done on Rails, including a deep dive into the new architecture for Rails connection management. Welcome, John. Thanks for joining me.
Hi, thank you for having me. My name is John, and like Eileen just mentioned, I also work at GitHub. I started working in Ruby and Rails around 2009 when I worked on a local news company called Patch. We had an issue where we wanted to build a calendar that had to support recurring dates, and my coworkers encouraged me, instead of building it directly into our application, to look at making a library for working with the dates. So that's what I did. I built an open source library called IceCube. I published it to GitHub, pushed it to Ruby Gems, and that was my first real experience in open source. I started to get contributions, and that's when I got really hooked. Since then, I've continued to work in Ruby and expand my knowledge, and eventually I got to work at GitHub where I could focus on helping others do the same. But even after contributing to open source and having plenty of Ruby experience, it still just felt wild to think that I could work on Rails. Something about working on the framework just seemed different. It's like the difference between using a stove and maybe trying to build your own stove.
I feel like if anyone here is going to build a stove, it's you. For those in the audience who don't know John, he's got a workshop and he's always building random things. Like he built a hot tub recently. So if he said, I'm going to go build a stove, I would 100% believe it.
I'd love to take on trying to build a stove. Some things, though, just feel different, like they're part of the fabric. It took me a long time to realize that Rails is just more software. And because it's more software, it has quirks, developers, real people behind it, people with emotions, and jobs and other obligations. I worked with Eileen a bit on the GitHub Rails 4 upgrade, and then over time, we became friends after noticing that we were at a lot of the same conferences and interested in a lot of the same problems. And it also helped that we both like drinking beer. Over time, we started pairing on various Rails bugs, starting with this thing that seemed really basic at the time, but it turns out actually wasn't.
So we wanted Rails to be able to infer the directory that migrations should be stored in and read from when using multiple databases. For example, instead of having to always set the migrations path to DB animals migrate or DB meals migrate, like in the database YAML example here, we thought Rails should be able to just figure it out based on the name of the database configuration.
Yeah, it seems really easy. Like, since we know the configuration name at the point where we're running the migrations, it should just be like a string interpolation away.
Yeah, so we made a PR and we made the string interpolation work, and it worked in our test app, and the active record test passed locally. So we thought, ship it, it must be done.
But then we pushed it up to GitHub, and if you've ever pushed a commit to Rails, you'll know sometimes the Railties test failed. I think we ended up getting them to pass eventually, but we noticed that the feature still wasn't actually working.
We spent a lot of time trying to figure out why it wasn't working, and instead of giving up, we just made a list of all of the things we thought we'd have to do to get it working correctly. And it turned out, to add this super basic simming functionality, we had to refactor a lot of how connection configurations worked.
Every road that we went down opened more paths of things that we would have to fix before being able to make the migrations paths inferred. And we went down a lot of roads.
We changed course many times and eventually realized that it's just a lot harder than we thought, because it can only work if we know which database is the default and should get assigned to DB migrate. Anyway, here we are almost 2 years later, and migration paths are still not inferred, but that's okay. We found that over time that we worked well together, and so we've spent a bunch of time building other features, like the sharding functionality that I described at last year's RailsConf. Today, we're going to talk about our most recent project, implementing granular connection swapping for multiple databases in active record. Before we get into that, though, we're going to briefly go over why a Rails application might need multiple databases and why re-architecting connection management for a third time was important for the scalability of large Rails applications.
So let's say you have an application that has a ton of data and traffic like GitHub. As the application scales, you're going to start to run up against the actual boundaries of how much data can be stored, how many requests the database can handle, and even things like how many open connections to the database are even allowed. When this happens, your database is going to start to crash regularly, and that's going to make your customers pretty unhappy.
In order to scale your application and keep it from setting on fire, your database is going to need to be split up. At GitHub, we actually have 15 databases that functionally partition our data, and like every day they're adding a new one. So each of those databases has replicas. For any given request, up to 30 database configurations could be in use. We also have a load balancer that can route traffic to specific replicas and tooling to add more replicas as needed, but none of that is handled by the Rails monolith.
For this talk, we're going to specifically look at how Rails handles multiple database connections and how it knows what connections to use when. To manage the multiple connections to all the various databases, we take advantage of the multiple database support that was built into Active Record by Eileen about 3 years ago. This functionality allows you to have multiple database configurations and to switch between them in your app.
Rails supports two ways of switching between connections. One way is automatic and the other way is manual. First, we're going to talk about the automatic switcher. The automatic switcher is enabled by a middleware defined in Active Record, which is partially shown here. There's a lot of other parts to it that I didn't put on this slide, but the most important part is the read and write methods. When a user makes a request, it automatically sends any writing request like patch, put, and post and delete to the primaries. The middleware guarantees what we call read your own write, which means that for a set period of time, we send follow-up get and head requests to the primaries as well. You can see that in the read from primary part of the read method. Otherwise, we send get and head requests to the replicas.
And this is really important because the replicas often lag behind the writing databases. So when there's a write, we need to send the next few reads to the writing database until we know that the replicas have actually caught up. In most cases, this happens in less than a second, but we still need to be able to calculate when it's safe to read from the replicas, because if we didn't, there might be a chance that the user would save something and not be able to see their own updates after refreshing a page. During the writing request, a timestamp gets stored in your session, and then we check whether a set period of time has passed since your write. If enough time has passed, we send your reading request to the replicas. Otherwise, we send your requests over to the primaries. If you've used multiple databases in your application before, you've probably also called the connected to method. This method's used internally by the automatic switcher, but it's also how we support manual switching. Manual switching is when you tell your application exactly when to switch connection roles or shards. It can be used on its own or in combination with the automatic switcher. As shown in the example on Eileen's slide, all of the connections are switched to the reading context until the block is exited. Connected to is designed, though, to only be called on Active Record base, which means that all connection switching is global. Person, dog, and lunch all get connected to the reading role in this example. They can't access the writing connections from within the block.
Let's take a look at how this is implemented internally in Rails with a brief history of connection management. When a Rails application is booted, established connection is called from the Rails HI, and a connection handler object is created. This object references a concurrent map called owner to pool, which is a mapping of the class name that established the connection, in this case Active Record base, to the connection pool. Since Rails 2.3, it was actually possible for the connection handler to have many key value pairs in the owner to pool mapping. This allowed applications to have more than one connection defined for the application, but remember, only still one per class. There was no support for calling established connection more than once for a given model. If you tried that in your application, the latter call would clobber the former one. Connections are keyed on the class that established the connection, so there was no logical place for Active Record to store multiple roles or shards in this architecture. This meant that anyone wanting behavior like sharding or replicas would have to add some wild custom code to get things working. Many years ago, a team at GitHub worked around this limitation by monkey patching Active Record to have a second connection handler as shown here for the reading connections. This allowed applications to establish multiple connections per class, one for each role. The writing handler holds the connections to the primaries, and the reading handler holds the connections to the replicas.
When Eileen was working on the 3.2 to 5.2 Rails upgrade at GitHub, she found that code and identified that it would be a really great candidate for upstreaming to Rails. It can be a lot of work to pull something that's been patched into an application out, convert it to match Rails style and sensibilities, and still keep the behavior grounded in the original intention of the feature. But this is how a lot of useful features make their way into Rails, through a bunch of hard work and time from dedicated people like Eileen.
This implementation continued to work perfectly for us at GitHub because we used functional partitioning and only ever switched based on the database role. However, this functionality could not support sharding, a feature that we were hearing more and more requests for Rails to support.
So last year, Eileen and I decided that it was time to tackle the sharding problem. We wanted to add support for it because multiple databases couldn't really be considered a mature feature without sharding. Many applications rely on sharding to split up their data. Figuring out where to put sharding, though, was a challenge. We wanted an API that looks like this. Here, connects2 can define a set of shards where each shard can also potentially have a reading and writing role. We couldn't implement sharding on the same level as the connection handler because not all applications are sharded, and because each shard could potentially have those writing and reading roles. We needed a way to group connections by their shard key for lookup further down the stack without breaking backwards compatibility.
We tried to implement sharding a bunch of times before we found something that worked. We threw out so many branches, I think at least 5 of them over time. And then one day, John came up with the idea that we could just insert another layer in between the owner to pool mapping and the connection pool.
And that's what we ended up doing. We introduced an object called pool manager, which holds another key value pair of the shard name to the pool config. And then the pool config holds a reference to things like the class name, database configuration, schema cache, and finally the connection pool itself. The APIs for sharding were merged last year before Eileen's keynote at RailsConf. And at that point, we were like, hey, we're done. We're done making changes to connection management internals. But of course, as we would soon find out, you're kind of never done.
You're never done, ever. It'll never be done. In June of 2020, a team at GitHub came to us with an interesting problem. While role swapping using a handler had worked well for us for many years, we started to have scalability problems. Because role swapping was global, the automatic database switcher was overloading the primary databases. Sometimes we write to certain databases more than others. For example, we update the timestamp when you read a notification more than we update your email address, and those 2 records live in different databases. The global nature of role swapping meant that all replicas had to be up to date before we could send any queries to them. When using the automatic switcher, this meant that we were sending all of the queries following a write to the primaries, even for databases that hadn't just been written to. Why should we need to send all queries to the primary if only one of the 15 databases just had a write? We had an opportunity to make the database switching code more efficient.
To improve the database switcher, we would need to make connection management more granular. We wanted to have more control over which databases read from the primary instead of swapping either all or none of them. If we could give application owners more control over switching roles, then we could probably reduce the number of queries on the primaries by ensuring that the only read queries going to the primaries were on databases that had a recent write. Since connection swapping was designed to be global, though, we were going to have to completely redesign connection management again to support granular swapping.
Personally, I wasn't psyched about rewriting connection management again so soon after implementing sharding. I was concerned that to support granular role swapping, we'd need to maintain 2 very different code paths in Rails. I was also concerned at how this would increase the complexity of tracking the state of each connection, and in addition, how much more complex it would make the code for application authors. However, John was sure that it wasn't going to be that hard, always with the confidence. So we wrote an internal project plan and got to work. The first thing that we needed to do was decide on what the public API would look like. This might sound a little backwards, but why not make the internals work first and then shove an API on top? Well, I don't like to write code like Rails for that, for Rails. I like to find the API that feels most natural and then make the internal code work with it. It's one of the reasons Rails is so nice to use. It cares more about your experience working with the APIs than it does about how pretty the internal code is. Rails often takes on complexity so that your application doesn't have to. In addition, this approach ensures that we don't make any backwards incompatible changes. If we know ahead of time what the public API is, we know that we can change all of the internals that support that API without breaking any existing application code. In this case, the public API had a clear and natural place to live. When connections are established, the connects2 method is always called on an abstract class, as shown here. It made perfect sense for us to then allow calling connected2 on those same abstract classes to enable granular swapping.
So let's take a look at how it would work. In this code example, the active record-based connected2 call would remain global, and within the block, it would switch all of the models to reading. Then to use granular swapping, we could call animals record connected2, like in the bottom example, which would only switch models that inherited from animals record to reading. We decided to only allow calling connected2 on classes that had established connections. We didn't want to allow calling connected2 on any model in the inheritance chain because it'd be much more difficult for Rails to keep track of the state of each model. And we also felt like it'd probably result in confusing, error-prone, and brittle code.
While this API worked really well for swapping a single connection, we also needed a way to easily swap multiple connections at once. If Rails only supported swapping via the connected to API, then applications would end up with nested connected to calls like this. Nesting calls is problematic for a couple of reasons. The first reason is that it's ugly. No one wants to write more than 2 layers of nested calls in order to switch 2 of our 15 databases to the writing role. The second reason is this wouldn't work that well in the auto-switching API. With this example, we'd have to send the classes to the middleware and then stitch together nested connected to calls. That's not an API that's in line with Rails ideals, nor is it one that we wanted to use at GitHub.
So to support setting a set of classes to a specific role, we decided to introduce a secondary API, which we called connected to many. It takes an array of classes as well as the normal arguments that go to connected to. So that's role, shard, and prevent writes. The connected to many API gives users a cleaner interface because it avoids the complex nesting. This example is pretty simplified, but you can see how an application with 15 plus databases can benefit from using connected to many over nesting multiple blocks.
Once we had decided what the public APIs were going to look like, we needed to figure out how to re-architect connection management to support the changes. The problem was the original architecture could not support granular swapping because the handler approach fundamentally keeps the writing and reading pools isolated from each other. We knew that we needed to move the role tracking somewhere else so that the writing and reading pools were no longer separated.
Eileen had the idea to create a set of diagrams about how everything worked. And when we looked at the diagrams, it became really clear that there was a logical place to move the role down into so that we could support granular role swapping. The work that we had done on sharding had accidentally created the perfect place to push the role into. To implement granular swapping, we dropped the second connection handler, and we moved the role down into the same hash that we had built for sharding. The mapping now goes from role to shard to pool config. To prove that this new behavior would work for granular connection swapping, we initially wrote a spike that just completely disregarded backwards compatibility in order to demonstrate that we could drop one handler, push the role down into the name to pool config mapping, and track multiple states for the connection classes.
The code that supports this new functionality is quite simple. When a connection is established, a pool manager object is initialized with a simple hash that represents the mapping of role to shard to pool config, as seen here. Rails looks up the pool manager from the pool config's connection specification name, which is the name of the class that established the connection. In this example, it would be animals record. Once this was created, we needed a way to keep track of the current role, current shard, and current preventing writes for every single class that called connected to. To track this information, we created a method called connected to stack, which returns a concurrent array object.
And then every time that connected to is called, we add the role shard, preventing writes setting, and the list of classes being switched into the connected to stack. We then execute the block, and then when the block is closed, we're free to just pop it off the stack, putting things back how they were before. In the end, this implementation that we ended up with was relatively simple, given that we had to re-architect connection management to support granular connection swapping. Additionally, the way that we chose to implement this made backwards compatibility really easy to support. Since the legacy version uses 2 handlers, the differences between the legacy and new swapping behavior allows us to use a lot of the same code paths without leaking behavior between versions. If applications opt into the new granular swapping, they get 1 handler with the role to shard to pool config mapping. Otherwise, they still get 2 connection handlers, each pointing to a shard and then to a pool config.
From the beginning, we knew that any of the changes we were making had to be backwards compatible, well documented, and tested. Literally every single Rails application on the planet that has a database relies on how connections work. So it was super, super important for this new behavior to be opt-in and not break anything. Luckily, Rails already has a common pattern for supporting multiple code paths and making new behavior configurable. To support backwards compatibility with granular swapping, we added a configuration option called legacy connection handling. The setting defaults to true for existing applications. For new Rails 6.1 applications, the setting defaults to false, so it effectively opts you in if you're making a new app into the new behavior, opts you out of the old behavior, to be clear. If your application uses a single database, you can opt into this new behavior right away. There are no changes that you need to make to your application at all. For any applications that are using multiple databases, you only need to make updates to your application before enabling it if you're interacting directly with the handlers or any of the other methods that use the handlers. The legacy connection handling is also deprecated in Rails 7, so you're going to have to migrate to the new handling eventually. In order to make the migration easier, we use this configuration option to raise an error if your application sets legacy connection handling to false, but then calls one of the methods the new behavior doesn't support, like the connection handler, getter, and setters. This helps inform application authors how to update their application for new behavior and prevent someone from accidentally mixing behavior between the legacy and new connection handling.
We also supported backwards compatibility by continuing to keep the behavior for active record base connected to as global. This means that if you switch your application to the new behavior, everything is going to work exactly the same. No queries will accidentally change to a different role or shard without you updating the class that connected to was called on. Now, it'd be really easy for us to stand here and show you how simple the design of granular connection swapping is and never mention the ways that we messed up. Most presentations just talk about what went right, but that's not reality. Just like you, we make mistakes sometimes, and this talk isn't about being perfect. It's about doing things outside of your comfort zone. This was a major change to Rails connection management. We drastically increased the complexity of tracking the state and the context of connections. So naturally, there were a few bugs that we discovered, some even after merging.
The first bug that we dealt with involved how the preventing rights code worked. Preventing rights is a feature in Rails that lets you block rights to a connection even if it's not a replica. Preventing rights is useful in a test environment because transactional tests share a connection and can never have true replicas in those cases. So we needed to know whether preventing rights was set to treat them as replicas. A contributor reported to the Rails issues tracker that when using granular connection swapping, preventing rights wasn't working. To understand why this was broken, let's look at how we implemented the check to preventing rights.
In the granular swapping behavior, we turn on preventing rights if the connection configuration is for a replica or if current preventing rights is set to true. And just looking at this, it looks totally fine. Except the problem is that we don't want to ask active record base if current preventing rights is true. We need to ask the connection class. By using active record base here, we're only asking if the global connection has set preventing rights to true.
In the places that Rails internally was calling current role and current shard, it was always called on self, which is the connection class. However, preventing rights method is defined on the raw connection, which meant that we didn't have direct access to the application connection classes. We needed to be able to call current preventing rights on animals record or meals record. To fix this, we simply made the pool aware of what connection class it belonged to. Previously, the pool would have to reach into its pool config to find out, but this change exposed the setting directly on the pool object. Once the pool was aware of what its connection class was, we could then call save constantize because the class name is always stored as a string, and finally call current preventing rights.
The second bug that we saw was a little bit more major because it wasn't caught until after we had deployed granular connection swapping to GitHub in production and started using it. The bug worked like this. Rails requires that your connections are set in an abstract class. We do this so that applications don't accidentally open more than one connection for a database configuration. It's a guard that tells application authors that they should connect to a database once and then inherit the models that want to use the connection from that abstract class. However, we had a flaw in our logic where the connected to stack assumed that there was only one abstract class in the inheritance chain. Some models have multiple abstract classes in the inheritance chain, like the example shown here. Dog inherits from mammals, which is an abstract class, and then mammals, in turn, inherits from animals record, which is both an abstract class as well as a class that establishes a connection. This resulted in us sending queries to the replicas before they were caught up. We had an occasional report of a user seeing a 404 after performing a write action because we had effectively broken the read your own write contract. Since GitHub doesn't have a lot of replica lag, for the most part, this went unnoticed, and we didn't catch it in our early testing because we had only been working with classes that had a single abstract class in the inheritance chain.
Because there could be multiple abstract classes in the chain, the Rails code, as seen on my slide, would stop when it found the first one, mammals, but we actually wanted it to keep going up the stack until it found the connection class, which is animals record. We couldn't just change Rails to keep going until it found the last abstract class, because that would break granular swapping for application record. It would effectively make it global because all other classes inherit from the base class. You can see that animals record inherits from application record. What we were seeing here was a conflation of two ideas. We had assumed for a long time that there was only one abstract class in the chain and that if it existed, it was going to be the one calling connects to. We didn't consider that there could be more than one abstract class for a given model. With granular swapping, we needed to be able to identify them as separate things and know which abstract classes had called connects to. Previously, we didn't need to worry about this because you could only ever switch on active record base, so we didn't need to know who established the connections.
To solve this, we decided to define a connection class instance variable on the class that calls connects to. Then, whenever the connection is established, we just update the value to true for that class. Then we updated the abstract base class method to be named connection classes, and instead of checking if the class is an abstract class, we just check if it's a connection class. The best part about this implementation is that application users don't have to make any changes to fix this in their applications. Once this bug was fixed, we were able to implement and use granular swapping in our custom automatic database switcher, and we've been running it for a few weeks now in production at GitHub. It's helped us reduce unnecessary queries on the primary databases.
If you're interested in using this feature in your own application, it's available in Rails 6.1. Even if you're not looking for granular swapping, the behavior for calling connected to an active record base remains global. That means that when you opt into the new connection handling, your application's behavior remains exactly the same until connected to is called on another connection class. This is a great example of a feature that provides a lot of value for larger scale applications while staying completely out of the way of smaller ones. We built granular swapping so that applications can scale their databases as they grow. The changes we demonstrated today allow us to reduce pressure on GitHub's primary databases and keep them running smoothly for all of you. At the moment, Rails automatic switching middleware only supports global switching on base. John and I are working on adding granular swapping to the middleware, but we had to work on this talk first. It was kind of a priority. We're hoping to get the automatic switching fixed in Rails for granular swapping by the time Rails 7 is released. We've learned a lot over the last couple years of pairing together, and especially working on this most recent project with granular swapping. So now we want to talk about some of the stuff that we've learned.
So as you probably know, writing software is hard. We didn't rewrite connection management once in Rails. We rewrote it twice, or possibly 3 times, depending on how you count. The diagrams that we looked at earlier illustrate each iteration over the years that we took to get to where we are now. And part of the reason that we spent so much time getting to where we are now is that there are a lot of Rails apps to be careful about not breaking. This wouldn't be a very fun talk if we had just broken all your apps. When writing software for open source, you need to consider not just your own application, but kind of every single Rails application in the world.
This is why backwards compatibility is so important. If we were to change the behavior of active record without regard for other applications like Shopify, Basecamp, or your application, it would harm the ecosystem. It will take longer for us to get rid of Cruft and longer to stop supporting legacy connection handling. But by making it opt-in and backwards compatible, we demonstrate empathy for our community and make it possible and reasonable for applications to stay on the latest version of Rails.
Like we said, we implemented this a few times, but somehow still ended up with bugs. Software doesn't have to be perfect the first time. You can iterate and collaborate on it, and then eventually it's going to be pretty good. I think one of the things that scares people away from contributing, especially to large open source projects like Rails, is that they think that things need to be perfect the first time.
There seem to be so many edge cases to account for and so many possibilities to make a mistake that it becomes paralyzing to contribute. But just remember, every time you make a mistake, you get another commit to Rails. Joking aside, John and I have been doing this for a while, and as you saw, we still make mistakes. But from each mistake we made and each branch we threw out and each bug we introduced, we learned a lot. And I wouldn't trade those learning opportunities for perfection.
If we had tried to build granular swapping the first time when Eileen pushed our internal handling upstream, we would have failed. It would have been too hard and too error-prone to guess what real-world applications would need. But by iterating as the application needed more functionality, we ended up building better, more stable, and more useful features into Rails.
So you might be watching this talk and thinking, well, I've paired before and pairing sucks, so I have no idea why these two want to do it. So I wanted to share a little bit about why we think our pairing is successful. I think that a lot of people think that pairing is just coding with your screen shared and you feel like a zoo animal, or they end up in pairing sessions where they're just watching someone else code and are kind of bored. The driver not driver setup that's typically done in pairing can create a dynamic where one person is in charge.
And that's not the kind of pairing that Eileen and I do. We often type over each other. Sometimes we're typing the same thing at the same time. Sometimes we're just typing like 2 totally different things at the same time. And that's okay. One, because it's funny, but two, because part of pairing is sharing control. It might not always be the thing I would type or the idea that I had or the road that I would go down, but it's important because the more debate and collaboration we have, the better end solution we end up with.
Even writing this part of the talk was an exercise in pairing. This isn't necessarily the talk that I would have written or that John would have written on our own, but it's the talk that we wrote together. That means that we debated how to say things a lot. We copy edited each other's notes, and we spent a lot of time trying to make the best talk we could. At one point, trying to make the best talk we could meant completely rewriting an entire section last Friday. But that back and forth collaboration is what makes pairing great. We always end up with something better in the end.
Also, sometimes I get tired in the middle of a problem. I'm sure you've all been there. Sometimes it's not a lot of work, but it's just really not the type of work that I feel like doing right then. Maybe it's how are we going to set up tests for this case? Or, oh no, I forgot about this edge case. The whole thing is over. I'm going to go throw my computer out the window. A lot of times when this happens, we found that those problems are the exact kind of problem that the other person does feel like solving. Pairing like this means that we're constantly pushing each other forward instead of just getting stuck and giving up.
If you've been in a pairing setup that didn't work well, it could also be because not all pairing setups work. Not everyone gets along or has the same coding style. Pairing is about finding someone that you work well with and can trust. You won't enjoy pairing if one person is bringing a ton of ego and needs to have full control or is always telling you how to do something. Pairing isn't about watching someone code or forcing your ideas on them. It's about collaboration and having fun. You also need trust and empathy for the other person in order to feel comfortable sharing ideas that you might otherwise keep to yourself. And that's why John and I enjoy pairing together.
So if this sounds interesting to you, try find someone that you trust and giving it a shot. Working on Rails can be a great time to find someone to pair with. Not only do you get two sets of eyes on the problem, which is important having such high traffic code, but Rails also has a bunch of really complicated parts. Having two people in the room means that you're less likely to do things like forget about an edge case or mistakenly remove code paths without a proper deprecation. So if you have something that you're afraid to do or think you can't do, pairing can be a good way to ease the feeling of risk. I'm able to contribute to Rails personally because I'm pairing with Eileen.
And that's kind of the core of what I'm trying to get across with this talk. That there are ways, like pairing, to make that uneasy feeling you get when trying to do something new feel a little better. Hopefully among the technical content here, you can see that we're just two people making mistakes until something halfway decent finally works. If you're out there thinking that you're not capable of stuff like we just talked about, know that you are just as capable. It just takes time and effort. You'll get there eventually. And remember, you don't have to be perfect. John, thank you so much for joining me for this conversation about how you started contributing to Rails, what pairing is like, and our deep dive into granular connection swapping.
Thank you so much for having me, and everyone enjoy the rest of Eileen's talk.
I hope that watching this talk so far has dispelled some of the mystery around how Active Record handles database connections, what contributing to Rails is like, and showed you some of the ways in which those of us who contribute to Rails and speak at RailsConf aren't perfect either. As I mentioned earlier, in order to accomplish things like speaking at conferences and contributing to open source, I had to overcome a lot of self-doubt and internalized fears. I didn't just wake up one day good at this stuff. When I was growing up, like most of us, I developed ideas about things that I was bad at and things that I was good at. And I carried those into adulthood. I was bad at math. I was good at art. I was bad at public speaking. I was good at problem solving. I was bad at foreign languages. I was bad at music. I was bad at sports. I wasn't smart. I wasn't funny. And all of those things added up to more things I thought I was bad at than things I thought I was good at. And all of those things I thought I was bad at were things I thought I couldn't ever do. I literally believed that these were flaws in my character, unchangeable, unmovable, unwavering facts about myself. I believed that deep down I was meant to be bad at math and bad at public speaking and bad at all of these things. In the last few years, I've started to actively challenge assumptions that I have about myself and try to overcome the self-doubt that I've internalized. We all doubt ourselves. We all tell ourselves we can't do this or we can't do that. We listen to the voices that tell us we're not good enough or not smart enough. I'm telling you these stories so that you can see I struggle with this too. I'm not smarter than you. I'm not better than you. I'm just in a different place along my path. There are so many times in our lives that people tell us we don't belong, that we're not good enough, that we should focus on something else. But the things that we think we're bad at aren't set in stone, and we can work to overcome them. Don't listen to someone who's there just to crush you and make you smaller. They don't deserve your brilliance. Over time, we can learn to quiet that voice that tells us we're not allowed to do something because we're not smart enough, or because someone laughed at us in a school presentation, or because we were never good at it in school. You can speak at a conference. You can contribute to Rails. You can be a better programmer. You can learn a foreign language. You can do math. You can do anything that you want to. We need to learn to listen to the other voice, the one that says, yes, I'm awesome and I can do anything I want to do. The first step to overcoming internalized self-doubt and fears is to ask ourselves, what are we really afraid of? What's the worst thing that can happen? When I really tried to understand why I was afraid of public speaking, I realized that I was worried about the same thing that happened back in high school so many times. I was worried that you'd all laugh at me or think I didn't know what I was talking about. I thought I might fall off the stage or die from embarrassment. By identifying what we're afraid of, we can work to understand that fear, where it comes from, how it started, and what kind of hold it has over us. Once you identify what you're afraid of, ask yourself, what's the best that can happen? I knew that if I could overcome my fear of public speaking, it would give me a stronger voice in the community, that I'd have a better career opportunities, and it would help build up my confidence. When you really take the time to dig into what you're afraid of, it starts to have less power over you. When you weigh the risk of letting your fears win against the rewards of overcoming those fears, the clear winner will always be working through self-doubt to achieve your goals. Identifying the best things that can happen changes your perspective. It gives you a reason to overcome those fears. Once you've dug into what you're afraid of and why, the next step to overcoming your internalized self-doubt is to do the thing that you're afraid of. Without making the decision to do something, whether it be to speak at a conference or contribute to open source or learn a foreign language, literally anything, you have to start doing the thing. You have to take steps towards your goals because only you can decide to ignore the voice that tells you you can't do it. No one else but you can say, okay, enough, I have to at least try. And that's what I did back in 2014 when I spoke at my first conference. If I hadn't decided that I would work through my fear of public speaking and just do it, I wouldn't be here keynoting at RailsConf today. I think that often we have a hard time overcoming our fears or achieving our goals because we try to solve too much at once. It's okay to start small and work your way up. Working towards our goals is quite similar to a large refactoring. John and I were successful in building granular swapping because we didn't try to solve all the problems the first time around. We identified blockers and one by one worked towards those goals. If you approach overcoming your fears the same way you approach a refactoring, it's going to feel more manageable. Our goals and successes are cumulative. You can't keynote RailsConf if you don't speak at your first conference. You can't get onto Rails core if you don't first contribute to Rails. If you want to speak at a conference, you don't have to get over your fear by trying to get that keynote slot. Start small by speaking at a meetup or doing lightning talks or a talk at a company lunch and learn. If you want to get into Rails core, start by reading the most recently merged pull requests. Try to fix an issue, upgrade your application, and send a pull request to improve the process and documentation. Once you're doing the thing and taking steps towards your goals, you have to keep showing up regularly and practice. I've heard that it takes 30 days to make a habit. 30 days to break down the feeling that you can't or won't do something. 30 days for it to stop feeling so hard. 30 days for it to feel a little natural. 30 days doesn't feel so long after a year of COVID, does it? A couple of years ago, instead of doing a New Year's resolution, I decided to commit to doing something I thought I couldn't do, which was learn a foreign language. I had struggled with Spanish in middle school and high school, and I was left convinced that I was incapable of learning a language other than English. I picked Italian because I was supposed to go to Italy for Ruby Day in March of 2020, and I wanted to see how much I could learn in 3 months before going. Well, I'm sure you figured out COVID happened, and I never made it to Italy. But I did keep practicing Italian every single day. I'm nowhere near fluent, but I've learned how to speak, read, and listen for more words in Italian in 1 year than I did in 6 years when I took Spanish in school. The problem wasn't that I wasn't capable of learning Italian or Spanish or any other language. The problem was that I needed to commit to learning it by practicing daily. I might never be fluent, but that doesn't matter. What matters is that I set a goal and I showed up for it. In addition to practice, you should measure progress. I think we often balk at measuring progress outside of work because we look at it as project management. However, measuring progress doesn't mean that like you should add items to a spreadsheet or a Gantt chart about your life. When I talk about measuring progress, I mean not losing sight of everything that you've accomplished towards your goals. Success and failure, contrary to what society wants us to think, is not a binary. You're not either successful or failing, because life, like a code refactoring or learning a new skill, is always a work in progress. Measuring progress towards our goals allows us to celebrate our wins along the way. If COVID has taught us anything, it's that a year is both long and short. While some would call it a lost year, I bet you could look back and see a ton of stuff that you've accomplished, even if it wasn't one of your original goals. If I measured my progress by traveling to places and speaking at conferences in other cities, then I guess on paper I failed this year. But we all know that's ridiculous because we survived and in some cases thrived this year. And in the past year, I got better at giving remote talks. I became a drastically better cook. I started learning to play the guitar, still terrible, but learning. And I was promoted from staff to principal engineer. Without pausing and taking the time to look back at my progress, I wouldn't realize just how much I got done in this weird long and short year. Measuring progress can be as simple as reflecting back on what you've done to get closer to your goals, or be as complex as using project management software for your life. It's up to you because these goals are yours alone. The most important thing is taking the time to celebrate your wins and accomplishments along the way, especially when it's hard. Sometimes measuring progress will help you realize that your process isn't working and it's time to pivot. Pivoting can feel really hard because sometimes it feels like failure, and then other times it feels like too hard to get off the committed course. Changing course isn't a mark of failure, though. It's a mark of success and maturity. I actually had a really hard time coming up with just one example of pivoting because we've all had to pivot so much during this pandemic. But over the past year, I grew tired of giving remote talks with traditional Keynote decks. I mean, I love Keynote, but remote, it's not as exciting. So I wanted to do something different because pivoting would at least make it interesting. I wanted to do something special for all of you that I wouldn't be able to pull off on stage. So I designed this talk that embeds me in my slides, includes a guest speaker, John, and allowed me to share some of my personal experiences with all of you. In the end, it was probably a lot more work than just designing and writing slides in Keynote, but I think I ended up with something unique and different. At least it wasn't boring. I hope you all enjoyed it. Pivoting means taking stock of the current situation, assessing what needs to change, and then implementing those changes. Sometimes it means scrapping everything you're comfortable with, like I did with this talk. There's no tried and true calculation for when you need to pivot. It's something you feel in your gut. If you gave something a good try and it's not working, look for things to change. Lastly, don't go alone. If you're working towards a goal and you feel stuck or alone or frustrated, ask for help. Sometimes asking for help means working together on a problem like John and I did with connection management. Sometimes asking for help means admitting you don't know how to do something, like I've done countless times when Aaron and I are pairing. Sometimes asking for help means admitting you're stuck to your coworkers. And sometimes asking for help means just telling someone else about your fears and failures. And just because your fears are yours doesn't mean you have to keep them to yourself until you move past them. We're all a lot more successful when we share our fears and our failures, our successes, work together, and collaborate on overcoming them. There's no reason to do this all alone. And all of the things I thought I couldn't do, like speak at a conference, contribute to Rails, learn Italian, work at GitHub, are now things that I can do because I decided to do them, because I investigated my fears, because I started small, because I practiced until I felt comfortable, because I celebrated my wins, because I was willing to pivot, and because I asked for help when I needed it. I hope this talk has inspired you to go for that thing you think you can't do. Maybe next year you'll apply to RailsConf. Maybe next week you'll contribute to Rails. Maybe tomorrow you'll apply to that job that you've been hoping to get, or download Mango and commit to learning a new language. Success isn't a binary. It's not a straight line. Success is not defined by what you can and cannot do. Success is a self-defined work in progress. It's taking all of those can't do's, taking away their power, and turning them into things you can do. Whether you're refactoring a difficult piece of code, building a complex feature, contributing to Rails, speaking at a conference, or overcoming any level of self-doubt and fear, your success is going to look a lot like the picture on the right, not the one on the left. Overcoming self-doubt and achieving success is not easy. That's why they call hard things a growth opportunity. There's no straight line to overcoming these obstacles, but if you employ the tactics that we talked about today, you can overcome your fears. If you take anything away from this talk, I hope that it's knowing that all of the things you think you can't do are the things you can do. Let's get started. Thank you, everyone. I'll be on Discord to answer questions after the talk.